The Autumnal Equinox 2017. Making an observation for Sly Sparkane's test, September 22nd, 2017. So the idea was to measure the elevation angle of the sun as it crosses the meridian. Can we learn about the shape of the Earth if we can measure the elevation angle of the sun? We may only be able to determine whether a measurement is compatible with a proposed shape. We may not be able to eliminate other shapes with one observation. Multiple observations, however, may give us more information, possibly enough to state, with high confidence, that one shape is most likely. That is why I decided to participate in the test proposed by Sly Sparkane. Sly Sparkane requested that as many people as possible measure the length of the shadow cast by a vertical pole or other object onto a horizontal surface when lit by the sun. The observation was to be near the fall equinox because of the special geometric alignment expected that day. He intends to summarize the findings of many observers to learn what we can about the reality of the Earth we live on. You may ask, why the equinox? I think Sly picked the equinox because it would check whether the position of the sun at noon supports a rotating Earth. If the Earth is a globe orbiting a distant sun, there will be 2 days during the year where the elevation of the sun as it crosses the meridian must equal 90 degrees minus the latitude of every observer. Multiple observers, both north and south of the equator, must get this result for it to be considered evidence compatible with a globe Earth. Any other hypothesis, such as a large flat plane with a small close sun, must be able to explain whatever this data shows, to stay in contention as a true description of reality. So to get ready, I laid out a horizontal whiteboard, erected a vertical tube, found my tape measure, and got ready to mark the length of the shadow. Please see my raw video at the following URL, which I have linked in the description. I thought about it and decided to make a test rig as big as practical to make it easy to see. Unfortunately, as I was recording, the video came out very shaky and with poor audio. I did not have a great camera to record. I used my cell phone for GPS and date confirmation. I was able to find a tube that I could support with a steel rod that together could maintain the 90-degree vertical angle. My base was a white ceiling board leveled in 2 dimensions. As seen in the picture, the length of the tube was adjusted to be 44 inches. So the basic facts were these. My latitude is 41.3208 degrees north, found from GPS on the phone. Time of the test was 12:45 p.m. September 22nd, 2017, per the meridian crossing time found on timeanddate.com. Length of the tube above the board, I adjusted it with black tape to get an even number, was 44 inches. Measured shadow length was 38.5 inches. The calculated tangent was 1.14286. This is just the ratio of 44 divided by 38.5. The expected tangent angle of a 48.68 degree angle was 1.13748. And here is the picture of the actual observation, finding a shadow length of 38.5 inches. So to summarize what actually took place, I found a difference in actual tangent less the expected tangent of 0.00538. This is a percentage difference from expected of 0.47%, which is less than 1/2 of 1% difference. Please let me emphasize that no attempt was made to pre-calculate an answer before the test was undertaken. I did not even know what trigonometric function would be appropriate until I researched afterwards. The conclusion is that the measured angle is quite close to what we would expect. And now, some final thoughts on testing reality. It should be clear by now that the sun rises due east and sets due west for everyone on the equinoxes. This experiment further demonstrates what the apparent motion of the sun is between those times. I predict that this test, done with at least 15 others as of this writing, will validate the original claim of what the sun's elevation would be on a globe. So, flat earthers say, trust your senses. Yet, every attempt I've seen them make to create a model so far has actually become more contorted with a greater number of ad hoc assumptions than in the consensus model. I saw the eclipse. I saw the transit of Mercury. Now I see the sun right where it's supposed to be. With verified predictions, why should I not accept such a powerful model as the best description of reality that we have? Thanks for watching.